everyone. So today I'm going to cover a problem where you are given a string, and in that string you are given a set of characters, and you need to find the minimum substring in that string which contain all those characters. So you need to find the smallest substring which contains all characters of string T. This problem is also called minimum window substring. Minimum window substring. It is also called as a minimum sliding window, and it is also called as controlling set. Okay. So let's say you are given an input string S, which is equal to hello world. Okay. And then you are given another string which is LRW. Okay. Now you need to find a substring in S which contains all the three characters, but that substring has to be smallest or the minimum. So if you look here, the smallest one is this, right, which contain all the characters from T. So your output is WORL, which contains all the characters from tree. Now there are other substrings also which contains W, L and R. Okay, so there are other substrings also. For example, there is this L O W O R L, O W O R L, W O R L D. I mean, there are a lot of substring which contain those three characters. Now let's think of brute force way. I mean, how you can do it using just brute force, right? So if someone tells me just do it a brute force way, what I'll do, I'll find all the substrings of the string S. Okay, so what first I'll do, I'll find all the substrings of string S. How much time does this take? So the substrings are, there are substrings starting from H. So one substring is H, then HE, HLL, and so on. Then there are substrings starting from E, substrings starting from L, L, O, W. So it will take me 2 for loop. So it will take me O of n squared n, right? Once I'm done finding all the substring, what I have to do next? For each substring, I need to check that it contains the same number of unique characters as G, right? So for each substring, I need to check if it contains same number of unique characters as in T, right? So once I get this substring, right, I need to check whether it contains L, R and W, right? So for each substring I need to do this check, right? So let's see if our T is something like this. Is equal to L O, sorry, O O, right? So what is a minimum substring which contains 2L and 2O? What is it? So that is L L L O W O, right? So that's a substring which contains 2L and 2O. So you also need to match. So there are 2L's and 2O's, so you also need to match. I mean, it could have more than that, but you need to match that it should have at least 2L and 2O, that substring, right? So you need to match the number of unique characters, right? So now, and then I'll keep the track of the minimum length of the substring and the minimum substring, right? So I have to keep the track of this which contains. So I'm going to keep track of the minimum length and minimum string, right? Which contains all those characters, which contains same number of, okay, which contains same number of unique characters as T, right? What is the time complexity? So for each substring I'm checking if it contains the same number of unique characters as in T, right? So I'm scanning the substring, I'm finding okay it has this many L, this many O, this many W, and then I'm checking it against the T if it's matching or not. So this takes O of n time, right? So the total time complexity is O of n is 3, right? Now let's implement it. Let's implement the brute force approach, and then we'll see the ways how to optimize this. Okay. So let's implement the brute force approach. So public string main window brute force, right? So you are given a string S, then you are given a string T, and what you do in brute force approach. So what I am going to do in the brute force approach is, first I'll find all the substrings, and then to match the count, what I'll do is here I'll create a map, okay, map T, right, which contain all the unique characters in T. So it will tell me that the L occurs 2 times and the O occurs 2 times. So I know that there are 2 unique characters in all, and I know the count of each character. Then once I find any substring, for example, once I find this substring, right, world, right, once I find this substring, I'll create a substring map, right, which will say W is 1 time, O is 1 time, R is 1 time, L is 1 time, and T is 1 time, right? But what I need is 2L and 2O. It doesn't have 2L and 2O. Let's create the substring map for OW, right? So what this will say, L is 2 times, O is 2 times, and W is 2 times, 1 time, and it contains L2 and O 2 times, and it covered all the unique characters. There were total 2 unique characters, and it has both of them. So that means this match, right, this substring match. And then I'll keep the track of minimum substring found so far, but this map. So this is how I'm gonna do, okay? I'm gonna create a map and see. Okay, so first what we are going to do is we are going to create a map of all unique characters in T and their count. Okay, so I'll create a hash map of character and integer, right? And it's a map T new hash map, right? So once I'm done, let's create it. So for integer I is equal to 0, I less than t dot length I plus plus, and then I'll see what is my character c is equal to t dot character at I, and I need to see if that character already exists in the map. If it doesn't exist, then I'll enter that character. I'll put that character in the map with a count of 1. So count is equal to map t dot, I'll get that character, the count of that character if it exists. If it doesn't exist, then I'll just initialize count with 0. So I'll get it or initialize count with my default value. So I'll try to get that character. If it's not there, my default value is 0, so count will be 0. Then map t dot put character c and count plus 1, right? So that's, I created a map of all the unique characters in T. Now what is the size of the map? How many unique characters it has? So the unique character is nothing but a size of the map, right? So that many unique characters I have. Now let's initialize min length and min string. So my min length is equal to -1 and my main string is an empty string. Okay, now my first step is to create all the substrings of S. Okay, so let's do that. Okay, so now let's create all substrings of string S. Okay, how you create a substring? To follow, you start from each character and you go at a different index and take that substring. Okay, so I'm going to start from integer I is equal to 0, I less than s dot length I plus plus. Okay, and then I have my another variable which is j, and j starts from I plus 1, right? So first we'll take character h, then he, right? So j starts from I plus 1 and it goes till the length of the string. So j less than equal to s dot length, and then j plus plus. Okay, now what will be my substring? Substring is equal to s dot substring starting at I goes till j, and the substring API, right? It doesn't include the jth character, right? It excludes. It goes from I to j minus 1. So you need to know that. Okay. Now Let's check if substring contains all the characters with the same count as in T, right? So we need to check that. So let's do that check. So check if substring contains characters with same count as in T. Okay, we need to check that. How we are going to check that? So we need to keep a variable which represent that number of unique characters we have matched so far, right? And let's take a map of the substring. So hash map character integer. So this is a substring map. Right? So now in this substring map is same as this one. Here I created the map for the substring. So that's this, okay? So we need to create that map, and then we need to match the count, right? So once you have created a map, we need to have one integer variable form, right? Which represent number of unique characters matched, right? We also need to, if there are two unique characters in T, then we need to make sure that our substring map has two unique characters and their count also matches, okay? So the form is to see that it has the same number of unique characters. There are 2, 3, 4 unique characters, then we need to match that, and then we'll compare the count also for each unique character. Now we already have a substring. So let's do this for integer key is equal to 0 key less than substring dot length key plus. Okay. Now let's take the first character of a substring. Character C is equal to substring dot character and key. Okay. Now we need to add this character to the substring map. If it's already there in the map, increment the count. If it's not there, add it with the count 1. Okay. So count is equal to substring map dot get by default. If it's there, get the count, otherwise set the count to 0. So that's my default value. And substring map dot put the character and its count plus 1. Now we need to match if there is the character T. Let's see. So we have the substring map, right? And if our substring map has character L in it, right? We need to match the count of L. Should be 2 here because in T. So first of all, we need to make sure that the map T contains that character, and then we need to make sure that the count matches. So map T dot get C dot int value. Okay, I'm doing this int value because the map stores the integer object, and you know very well, right? In Java, When you compare the two integer object using equal operator, then Java doesn't compare them by value, but it does a reference comparison. So what this means is, even if the two integer they have the same value, equal can even return false because they are two different objects in the heap. So that's why we should use equals method to compare object, or we should use int value to get their integer value and then compare it. Okay, so here I'm going to use the int value and then I'm going to compare it. Okay, so let's do that. So that int value should be equal to substring map.get c dot int value, right? So if that's the case, that means, like, suppose there are 5 unique characters, so we also need to keep the count that how many are matched, right? So we'll do found plus plus to keep the track of how many are matched. Okay, now when all are matched, right, so when found is equal to mean t size, means all the unique characters are matched, we'll update the mean length and the mean string, right? We'll keep a track of the minimum substring that we have found so far, right? So when all are matched, right, that means we found a substring which has all the characters from T in it, right? And let's update the minimum substring. So if mean length is -1, that means we haven't updated this, or if mean length is greater than substring length, right? Substring length. If that's the case, then we'll update the mean length so mean length is equal to length of substring, so that's substring length, and mean string is equal to substring, right? So we are done with this if loop, done with this if loop, done with the key for loop, then done with the two for loops also, the J and I. And then we are going to return mean string, return minimum substring that we have found so far. So that is a brute force approach. This is not very optimized approach, as you can see. It's not linear, and there is a space also that we are using this map to store the map T and substring map. So S plus, there is a space which is S plus T, and over the time complexity is not linear. So let's think of a way how we can do this, how we can optimize this approach. Okay, so let's think again how to optimize this approach. So let's optimize this brute force approach. Now, here what we are going to do in this optimized approach is we are going to take a window. We'll use left pointer and a right pointer I will take that window and we'll slide that window. Okay? So, for example, our string is hello world. Okay, so H E L L O W O. Okay, and now your T is, let's see, it's L L O O. Sorry, O. Right. So what we are going to do here is, initially our left and right pointer both are at H. Okay. Then we'll increment the right pointer. The left pointer will still stay there. We'll increment the right pointer. We'll see. Does it have the characters from T? No. We'll keep incrementing the right pointer. The right pointer will go here. It will go to L, L. Still, we don't have all characters from T. It will increment, 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 increment. And then now here at this point, the left is at H, the right is at O, right? And we have all the characters from T, right? So here if you look, right? So this is string T, okay? In our map, T is something like this. We have two L's and we have two O's. And total number of unique characters are also 2. Okay, now here we have all the characters. Now if we create a map of this, where we have H1, E1, we have L, L2, we have O2, we have W1, right? So now we have 2L and 2O, and this is one substring. So we'll record its length. We'll record the left pointer and the right pointer. Okay. So what is the length of this substring? Length is 7. The left pointer is at 0, and the right pointer is at 6. Okay. Now what we need to find the minimum substring, right? So what we are going to do here is we'll squeeze from the left, okay, and we'll keep squeezing until we have all the characters, and we'll keep squeezing. If we have all the characters from T, here we'll keep squeezing the left. So if I squeeze left, right, so if I move left to here, right doesn't move. Right stays here also, okay. So if I move left here to E, right, still it's a valid, right? The substring has all the characters from D. It has 2L and 2O. So I can keep squeezing left, okay. So I'm gonna squeeze left again. Okay. Still, right, with the squeeze also, it has 2L and 2O, right? So at each squeeze, right, I'll update this minimum length and the left right pointer. So right now the minimum length is 1, 2, 3, 4, 5, 5, and the start is 1, 2, and the end is 6. Okay. Then I'll again squeeze the left. It will go here. With this squeeze, right? No, the L is 1 and O is 2, right? So now we don't have, it's not matching. Okay, so when that happens, we'll expand our right pointer. Okay, so I'm gonna move my right pointer like this. Do I have 2L and 2O? No. Then I'll move my right pointer. Oh wow, I have 2L and 2O. Again, I'll record the length of this substring if it's minimum. Is it minimum? 1, 2, 3, 4, 5, 6. It's 6, but I have already minimum substring of length 5, so I'm not going to record that. Right? Now I have found the substring. So let's try to squeeze the left pointer and see if we can find minimum. So I'm gonna squeeze the left pointer, but as soon as I squeeze the left pointer, my L becomes 1, so I'm not able to find the substring. And let's expand the right pointer and see if we can find the substring. Okay, now we are done. No, there are no more string. We are done. So this is how you're gonna do. Okay, so what we are going to, let's write the approach, step by step approach. Okay, what we are going to do. So let's see. Okay, by the way, the time complexity for this approach. Okay, let's discuss it. Let's write the approach first. Okay, one node. Okay, to cover the edge case. Okay, so if there is no such window in us, right? I mean, you are not able to find any substring which contain all the characters from tree. So if there is no such window in as that covers all the characters of T, right? Then you just return empty string. Okay? Just return the empty string. And if there is a window, you are guaranteed that there will be always one minimum window in S. Okay? Now let's do this. Let's create a map. Let's write the approach. Okay. So our approach is we are going to create a map of all the unique characters and their count in T. So create map of all unique characters and their count in T. Okay. What is the time complexity to create this map? For of T, right? Once we created this map, what we are going to do is we are going to create a map for this current window, like for this one, right? Or the window between our left and right pointer, right? So keep the map for current window and also keep an integer font. What is this font for? To keep the characters, unique characters in the current window. Font to keep track of unique characters in current window that matched to that in map of P. Okay. So now here we are sliding the window, right? We are expanding our right pointer. Once we find all the characters, we try to squeeze our left pointer. If we cannot squeeze our left pointer anymore, we again try to expand the right pointer and keep the map of it. So this takes all S time. Okay. Now what we are going to do? So keep incrementing the right window until what time we increment? Until we found all our unique characters, until font is equal to map T size, right? And once we find all of them, right, try squeezing from the left side to see if we can find the minimum substring. So try squeezing the left pointer till we have, try squeezing the left pointer until we have font is equal to map soon as while squeezing the left pointer, if the font is less than the map t size, stop squeezing it, okay? Then try to expand the right window. But when before you squeeze from the left, okay, keep recording the minimum window left pointer and also the right pointer. And then repeat step 3 of expanding the right window. Okay? If the left window cannot squeeze anymore, to increase the right window. Okay? So the time complexity, overall time complexity for this approach is S. Complexity is S plus 3 and the space complexity is also S plus 3 because we are creating a map for T and we are also creating a map for our current window, right? And the current window in the worst case can be the whole string. Okay, so the space complexity is also S plus 3. Now let's start the implementation. Okay, so we are going to return the minimum substring which contains all the characters. So main window, and we are given string S and string T. Okay, and what are our base case? Our base case is if any of the string is empty, right? So if S dot length is equal to 0 or T dot length is equal to 0, if there is any of this case, then we are going to return empty string. But if it's not empty, right, then first thing we are going to create a map of all the unique characters and their count in T. Okay, so create map to keep count of all unique characters in T. Okay, so let's do this. Let's create a hash map of character and integer. Let's call it map T because it's a map of all the unique characters and they're counting T. So new hash map. Okay, and let's run a for loop to add the values to this hash map. So integer I is equal to 0, I less than T dot length I plus plus. Okay, now so integer count. Okay, if there is a character in the map, then we are going to increment that count. If there is no character, then we'll enter a new character with the count 1. Okay, so count is equal to map T dot get or default. If it exists, get that count. If not, then set count to 0. So T dot character at I, and that's my default. And then map T dot put character T dot character at I, comma count plus 1. Okay. So that's done. Now what is how many unique characters does the T has? So that's the size of the map. So map T size is equal to map T dot size. Now we are going to do a sliding window. So always in the sliding window you have a left pointer and a right pointer. So let's take the left and right pointer. Okay. So our left pointer, integer left equal to 0, and our right pointer, integer right is equal to 0. Okay. Now we are also going to keep an integer formed, right, to keep track that how many unique characters are mapped in the current window. Okay. So formed keep track of how many unique characters in T are present in current window. So formed keep track of how many unique characters from T are present in current window. Okay, so that's integer formed, which is equal to 0. Okay, now we are going to also create a map for the current window. Okay, and the count in the current window. So map of unique characters and their count in current window. Okay, so that map will be hash map of character integer current window is equal to new hash map. Okay. Now we need to keep the track of the minimum window length and its left and right pointer. Okay, so for that, so we need to keep track of minimum window length, then we need to keep track of the left pointer and right pointer. Okay, so integer min is equal to just a second. So that is equal to -1, 0 and 0. Okay. Now we are going to start expanding our right window. Okay, and till what point will I expand? Will I expand till we have all the characters, unique characters and their count matching. So expand right window. Okay, so while right is less than s dot length, we are going to expand it. Okay, so we'll take one character and we will include it in the current window. Okay, so character C is equal to s dot character and right, and let's add this character to the current window. So add to current window, right? Now if there is a character already in the current window, increment its count. If not, then add this character with the count 0. So integer count is equal to current window dot get or default c comma 0. Okay, and then current window dot put c comma count plus 1. Okay. We also need to check if the frequency, right, if the count matches to the one in the map T, then we're gonna increment the font. Okay. Formed is how many unique characters have been matched. So if frequency matches to 1 in map T, then increment formed, right? So if I have L2 in map T and then in my current window I found L2, right, then I'll increment the font. That means I match one unique character and its count. So if map T dot contains key C and current window dot get C. So here I'm going to use the int value. Why? Because the map is the integer object and you cannot compare the integer object using equals in Java. Why? Because Java doesn't compare the objects by value, they compare it with a reference. So even if two integer values are equal, it might return false. Okay, so integer value is equal to map t dot get c dot int value. Okay, if that's the case, then what we are going to do is we are going to implement the form. Okay, so let's implement our form. Okay, now we are going to check, right, if we matched all the characters and their count, right? When do we match all the characters and the count? When formed is equal to the number of unique characters in T, which is map T size, right? So when formed is equal to map T size, what we are going to do? We found a window, we'll record the minimum, and then we are going to try to squeeze from the left and see if we can find any other minimum window. Okay, so squeeze the left window. Okay, right, so what we are going to do is while left is less than equal to right, and we are going to squeeze till we have formed is equal to map T size. Now the formed match the map T size, so record the minimum value first. Okay, and then squeeze the left. Okay, so record minimum window length left and right, and if just give me 1 second. So if minimum of 0 is not equal to -1, or equal to, if minimum of 0 is equal to -1, means we haven't found any minimum yet, and right minus left plus 1, right? If that is less than minimum of 0, then update the mean length, that is min of 0 is equal to right minus left plus 1, and negative left and mean of 2 is equal to right, and there you go, we are done with this. Okay, now we are squeezing the left window, so we need to remove that left character, right? So what is the left character? As left character at left, so we need to remove the left character from the current window. Okay, so let's remove from current window. Okay, so let's do this. Current window dot put character C, and its count should be -1. So current window dot get C current window dot get C -1. So that removed the left character. Now we also need to make sure, since we remove the left character, we need to update the font if it's required. So if map t dot contains keys and current dot get current window dot get C dot int value is less than, if it became less then map t dot get C dot int value, right? And the count decreased, right? So now that character is not matching anymore, that unique character. So we have to do font minus, and then we need to squeeze the left pointer. So we need to move or squeeze the left pointer. So that is left plus plus, and this close this while loop of squeezing the left pointer. Okay. Squeezing from left. Okay. Now if we cannot squeeze from left anymore, right, what we are going to do? We are going to expand the right. Okay, so this is keep expanding right window. Okay, so we keep expanding the right window, and just close the window while right less than a stop line. Close that, and when we are done, right, we will return the minimum substring. So we will return, now if minimum of 0 is equal to -1, then that means we haven't found a minimum substring. Okay, so we'll return the empty string, otherwise we'll return as dot substring min of 1, which is our left pointer, and min of 2, which is our right pointer, plus 1, because class character is excluded, so remember that you need to do plus 1. So that's our minimum substring, and that's it, we are done. So this approach is a linear approach, so we keep a sliding window. We expand the right first. Once we find all the unique characters and their count matching, then we try to squeeze from the left. If we cannot squeeze from the left anymore, then we expand the right. So that's in a nutshell what the approach is. Thank you so much for watching this video.